Otherwise, Andy was in earlier along with Lorraine and Anne. You are welcome, Anne. And in the worst case, I may have to do this over inside the building, which I'm actually enjoying better. Thank you, Lorraine. Okay, so I'll go over really quickly what you may have missed because of the static. And again, apologize for the technical issues. This is a thermometer. It measures temperature using a liquid inside. When it gets warm, the liquid expands and goes up. When it gets cold, the liquid goes down. Old thermometers used to use mercury, but mercury is a toxic chemical. It can hurt you. So newer thermometers use alcohol. Even though it's tinted red, it could be alcohol. This thermometer has two scales. The F is for Fahrenheit. The C is for Celsius. Now, these were the names of men hundreds of years ago who came up with the temperature scale. The Fahrenheit scale is mostly used in the United States. The Celsius scale is used in most other countries because it's also called the centigrade scale. And you know, centi means 100. A person who's 100 years old is a centurion. We just came into a new century 20 years ago. So the centigrade scale is used around the world. And the great thing about it is it tells you at 0 degrees, water freezes. At 100 degrees, which would be way up here, water boils. So that's your typical thermometer, good old-fashioned one that you may have on your wall outside. I showed this other thermometer, and this is one that some of you may have on your patio. Now, I took the needle off on purpose so that you can see there's metal on the inside of that thermometer. It's a metal coil. And when the heat warms the thermometer, the coil will start to stretch out and unravel. And if you attach a needle to it, it makes the needle go higher. And when it cools down, the metal starts to contract or squeeze back in together, and it makes the needle go down and show a lower temperature. So that's another way to measure temperature. And as I mentioned, outside here at NBC 15, it is warm. My first thermometer shows a temperature of 82 degrees. It's really not that warm, but it's picking up direct sunlight. So when you have a thermometer, you don't want to put it in direct sunlight. You need to put it in a shaded area. And for a weather station, like the one we have on our rooftop behind me, there are electronic thermometers that are really tiny, and they go inside of something like this. And you could put a thermometer in here and other weather instruments, and what this does is it protects it from direct sunlight, it protects it from rain, and it allows the wind to blow through, so you can actually measure the air, not what's moving in the air or how much sunlight you have. So here's my question for you all. I need your answer. There are 3 ingredients that make weather, and that means there are 3 basic weather instruments. I just showed you one of them, and that thermometer measures heat. That's the first ingredient you need to make weather. Now, the heat for our weather comes from the sun. The sun heats the earth. Name one of the other or any 2 of the other weather ingredients, simple 3 ingredients that are used by nature to make weather. And while we're doing this, I'll check back. Thanks for bearing with me through the technical issues. Thanks, Amanda. Hi, Betsy. There's Carla. Thank you, Roseanne. Excellent, Justin. All right, and you grown-ups too, you can guess. Heat is 1 ingredient to make weather. 2 more ingredients. Okay, Alan Waldo came in. He's next. He said humidity or dew point or water. Yes, all of the above. So you need heat from the sun. You need water, humidity in the air. And I just gave you a hint. 1 more ingredient. Okay, Robbie's on track. He said wind and water. Wind is air. Wind is simply air that's moving. So the 3 ingredients to make weather: heat, water, and air. And for that reason, this is a tool that meteorologists have used for hundreds of years. Notice it has no wires. Each one of these is a weather instrument that measures one of those 3 things. And I'll give you a hint. Here's the first one. This measures heat. That's your thermometer. And if you write the word down, the word is actually thermometer. So all 3 of these are meters that measure those 3 ingredients. This measures therms, which is heat. The second one, let's see if I have this right. Okay, excellent. So here's your hint on the second weather instrument. This one measures the thing that people with long hair don't like in the summertime, because it makes their hair do something strange. So this second weather instrument measures something that makes people's hair go out of control in the summertime. Can you guess what that is? And I'm looking for your answers. Here's your thermometer. There's the middle instrument, which is the one we're talking about right now. And I have a little delay on your answers, so if you've already answered the question, it'll pop up on my screen in just a moment. So the hint on this second middle weather instrument, it ends with the word meter. It starts with the letter H. And it measures the thing that makes your hair go out of control in the summer. All right, I'll give you the answer. The answer is hygrometer or hygrometer, also called a hydrometer. You think of hydrology, the study of water, and hygrometer is an instrument that measures water floating in the air, which is relative humidity. So that's what that middle instrument measures. Bunny got it correct, and B got it correct. It measures humidity. And the humidity is what actually makes you feel uncomfortable when there's water floating in the air, because your body can't evaporate your perspiration. All right, so speaking of humidity, all right, this little experiment was working, but I've been out here so long, my ice is melting. See if you could see right there on the edge of that glass, you could see a little moisture. Now inside the glass is water and ice. I'll turn it a little bit. Yeah, so it looks like you can see it. That is moisture that was in the air. And what I did was, when I put the ice in the water, the ice cooled the temperature of the water all the way down until the water temperature equaled the dew point temperature. So that is dew. And that tells you at what temperature water will condense in the air, whether it's a cloud, whether it's dew on the grass. So that's why we use dew point temperature. And right there on that part of the glass, the relative humidity is 100%. Everywhere else, it's not as cold, so it's lower than 100%. And I need that right now. Okay, so temperature, humidity, and here's a kind of cool weather instrument. I'll show you this one. It's a thermometer that goes down and comes back up. And what's really hard to see here is inside the thermometer, there's a little metal thing that looks like a dumbbell on that side. And where's the other one? The other one is way up here. This is a thermometer that measures the lowest temperature of the day and the highest temperature of the day. So for example, the low temperature, and I haven't reset this. So this one, on the right side, when the mercury goes down, that little dumbbell floats down and then it stops. And when you read it, it tells you what the lowest temperature of the day was. On the other side, when the temperature goes up, the mercury rises, it pushes the other dumbbell up, and then that dumbbell stays in place. So this is called a max-min thermometer. It measures the maximum and the minimum for the day. And this is the old school way of doing it. And to reset it, there's a little button right here. If I just press that button, then it resets. Well, this one's so old, it's not resetting. But it will reset, and then it will measure the next day's maximum and minimum temperature. So that's a max-min thermometer. All right, last instrument on our instrument cluster. We talked about thermometer, hygrometer. The last one measures air pressure. And it starts with the letter B. It ends with the word meter. So thermometer, hygrometer, blank meter. Even though we say thermometer, hygrometer, and so what is it? Meanwhile, Jillian has a good question about what is mercury? So mercury is, everything on Earth is made of something. And the things we're most used to is water, air, even wood and metal. Let's talk about metal because that's easier. When there's metal, you can have iron metal, metal of iron. You could have metal of silver, metal of gold, metal of magnesium. I mean, there are all these different kinds of metals. Mercury is a liquid that's used in weather instruments that is like a lot of other different liquids, whether it's water, boy, I can't remember the other one. Someone help me here. But mercury is a liquid that is dangerous to touch. It's also the name of a planet, but we use it as a liquid. All right, our last weather instrument, I don't see the answer there, is barometer or barometer. So the barometer measures air pressure. So thermometer, hygrometer, barometer, these measure the three basic ingredients for weather. With the barometer, I need to show you my barometer. Hang on. This one I keep in a box because I don't need to use it, but I use it to show people. That is a barometer, and it measures air pressure. And now air pressure is really weird because it's something that you don't notice until it changes very fast. So you'll notice air pressure when you're flying up in the air in an airplane and your ears start to pop. Or let's say you're in downtown Mobile in the RSA tower and you take the elevator way up or way back down, you can feel the change of pressure in your ear. So that is air pressure. We are like fish swimming in the ocean, except we live in an ocean of air, and there's air on top of me, air on the side of me, air underneath me, and air inside of me. And all of that is air pressure. So air is something really important to talk about. And before we do so, you're welcome, Jillian. Before we talk about air, I'll give you an easy one. And again, I have to step out of the picture. All right, in my hand, I have a weather instrument. And right now it's actually working. It measures two things. They're both related to air. So we had a thermometer, a hygrometer, a barometer, and I'll give you the name of this if you can figure out what it does. That kind of tells you right there. Or so that moves with the wind. This is called an anemometer or anemometer. But anemometer, these little cups, when the wind blows, each cup catches the wind and it starts moving. And this tells you how fast the wind is blowing. So that's an anemometer. On the top of it is another weather instrument. And this one moves from side to side or around and around. And even this one is working right now. So right now I am facing south and it's pointing toward the east-southeast. And what this weather instrument is doing is it's telling me where the wind is coming from. So this is called a wind vane. Wind vane. And you'll find these on tops of old buildings, especially on top of barns, because the farmers need to know the wind direction. So this is telling me the actual wind speed and wind direction. And the one we have on our rooftop here at NBC 15, I can get the digital data off of my readout like this. And it's saying the wind is only about 2 miles an hour. So it's not very strong today, which is nice. It's a pleasant day. In fact, 77 degrees, that's our temperature here. And the humidity, 32%. So that's pretty good. Okay, Amanda got it right with wind direction. So that's an anemometer and a wind vane. This is another one. It's just a slightly different style. And again, if I move it that way, no matter which way I move it, the wind is going to push it back to point into the wind. And when we talk about wind, it's like meeting someone for the first time. You say, hey, where are you from? And the wind will say, I'm from the southeast. And we know on the Gulf Coast, a southeast wind starts to bring our humidity back up. So that's a wind vane and an anemometer. All right, so back to my barometer. which I was in the middle of showing you how this thing works. This is really cool. So the barometer has a needle on the inside, and this is what is actually inside this box. So I'll try to give you a good view of it. It is a little metal container, and it looks like copper. That's another type of metal. And the copper is airtight. No air can get in, no air can get out. And what happens is when the air pressure increases, this little copper container squeezes together. And when it squeezes together, let's see if I have to work this with my fingers carefully. It is right over. Okay, it may be broken because I keep it jumbled up with my other stuff. All right, here you can barely see it. When that metal squeezes together, this little lever moves back and forth like that. And when that little lever moves back and forth, connected to here would be the needle that goes side to side. So really cool weather instrument that's been used for hundreds of years, a basic barometer. Hopefully you were able to see some of the detail on that. All right, so here's a trick question. What kind of weather instrument is this? What would this measure? You know it's a sponge, but what could a sponge measure? I'm checking on your answers. And again, your answers might be a little delayed based on my signal here. A sponge measures water, but if you leave it outside on a very humid day, the sponge will start to expand a little because it's soaking up the moisture in the air. So a sponge can measure relative humidity. It's also another way to measure moisture, water in the air. How many of you have rain gauges? These are old style rain gauges. All they are tubes. The water falls in it, and on the side of the tube are numbers, and those numbers tell you how deep the water is. 2 inches, 3 inches, 4 inches. And then on this side, it uses millimeters. And that's what's used in other parts of the country to measure how much rain falls. This is just a different shape, and you could buy these at a lawn and garden store. These are about $5, $6, $7. But there is a more cool rain gauge like this one. This is a rain gauge. It's a bucket, and it has a big opening, and inside the opening, it has a little tiny hole, and it almost is shaped like a triangle. So what this bucket does is it could take a very small amount of rain, and when it finally goes down into that little hole, it magnifies it. It makes it seem like a lot. So this bucket at the bottom has this. So when a single drop of water falls into this side of this little device, it goes that way. And then the water drains out and falls out. And when another single drop falls in, it goes that way. And the water goes out. And each time this goes back and forth, it sends a signal to a computer. So that's, again, what we have on our rooftop to measure rainfall. And when it's raining really hard, this thing is moving like that. It's just non-stop when we get our downpours in Mobile. So this is called a tipping bucket rain gauge. And you'll see these on top of buildings, on top of bridges, places where people can't get to empty it out. So a really clever device. So that's a rain gauge. I'm saving the best for last. Two really good things here. Garrett was correct about the sponge measuring the water. Here's another tipping bucket rain gauge. This one's smaller, and instead of having a seesaw or a teeter-totter, this one just has a single. It's almost like the here's an old school one for you. The game at the amusement park where someone sits in a booth, the dunking tank. You throw a ball at something, when it hits it, they get dunked. So a little drop falls in there, and it dunks and lets it fall through. And then another drop comes in, it dunks and lets it fall through. So this is also a rain gauge. Technology. Okay, two more. Oh, I didn't show you I was showing you the thermometer, the hygrometer. This weather instrument, I'm going to show you the back of the hygrometer, because this one also has a coil on it. And when you look at the coil, it's metal, but it also has cotton wrapped around it. So when the air gets very humid, very moist, the cotton will soak up the water and the cotton will stretch, and that makes the coil twist. So when the air is very moist and the coil tightens up, it makes the needle go toward 100%. And when the air is dry, it relaxes and the needle goes back the other way. So that is a hygrometer or hygrometer, thermometer. All right, so before I wrap up, I can tell you that right now, straight up above my head, even though it's about 77 degrees here at NBC 15, 3 miles up in the air, it's about 32 degrees. I can go online, I can show you how I know that, but I don't have a computer behind me. If you go up about 6 miles, the temperature is about 40 degrees below zero. How do I know? Well, there's a weather instrument for that, and it's a weather instrument that looks like this. So just study that. It has a little sensing device, a little electronic sensor. It has a radio transmitter, and it has actually this is for tracking it, and this is the radio transmitter down here at the bottom. I'll open it up, and when you look inside, you see a computer chip. So this little device is carried by a balloon, by a weather balloon, up into the sky. It's launched twice a day around the world at the exact same time. For us in Mobile, the closest spot where it's launched is Slidell, Louisiana, which is that way. And this is carried by a weather balloon. It can rise as high as 20 miles in the air, and it can travel as far as 100 or 200 miles with the wind. As it's moving, you track it with an instrument, and that tells you how strong the wind is. But it measures temperature, humidity, pressure, and you can track it to get the wind. So this is how we know every day what's going on up above our heads. Now, the weather balloon, when it starts off, it's about 6 feet across. And when it goes way up there where the pressure is low, the weather balloon expands. And don't let me forget to talk about balloons, because they expand when the pressure is low. And when the balloon pops, because all balloons pop, this falls to the ground. But it has a parachute, so it falls slowly. It has a bright orange parachute. And one day you may find this is actually called a radiosonde. You may find a radiosonde stuck in a tree. You may see it stuck on your lawn, and it'll say on the outside, harmless weather instrument, so that it doesn't scare people. And then the new ones have a second half to it, where if you open it, there's a plastic pouch. You can put this in the pouch, take it to the post office, and they'll mail it back to the National Weather Service, and they'll try to use it again. Now, they don't get too many of them back, but it's always nice to get them back. Now you can keep it if you want, but if you keep it, make sure, and I can't show it where it is, but there's a battery inside of here. Make sure you take out the battery so the battery doesn't leak. So that is carried by a weather balloon that goes up into the air twice a day around the world. Now, I have had the chance to fly with the hurricane hunters out of Keesler Air Force Base 3 times into a hurricane. And when you're in a hurricane, it's not dangerous if you're a professional, and they're professionals, they know what they're doing. They're taking weather readings. And while they're taking weather readings, they're using a weather instrument like this. I'm going to give myself a little more room here. So this weather instrument, I'm going to back up, actually has a parachute. And it's a tube, a cardboard tube, and inside the tube is another computer chip. And this one has some batteries, and this weather instrument is dropped from the Hurricane Hunter airplane. Now, it's only dropped over the water because this is heavy. If it hits you, it will hurt. So they only drop these over the water, and the parachute keeps it from falling too fast. And while it's falling, it has a GPS transmitter, so it's sending data up to a satellite on where it is, what altitude it is, and it's sending the weather data up to the satellite, and then it comes back down to the ground to the National Hurricane Center. You can get it on your home computer. So this is the device dropped from the Hurricane Hunter airplane. This one is launched by a weather balloon. It goes up. This one is dropped. It goes down. Now, I'm not sure how much these cost, but they're not too expensive. This one, I can tell you, it's about $500 because it's a very precise instrument. And in a typical hurricane flight, which is 8 to 10 hours, they may drop 20 of these. So they'll drop $10,000 of these into the ocean. But it's worth it because the data is critical. The data is valuable. All right, I have one last thing to show before I wrap it up. Make sure I didn't miss any questions here. So back to the balloon. Here's a simple balloon, and this is an experiment you can do at home. Simply blow up a balloon, use a piece of string to wrap around and measure how far around the balloon is. That's one way you can measure it. Put the balloon, well, write it down so you don't forget. Put the balloon in your freezer for about 10 minutes, and then take it out. And as soon as you take it out, measure it again and see if the balloon is bigger or smaller. And that tells you something about temperature and pressure. So this balloon, this one's pretty happy. This is the happy balloon. And inside of it is air. So if I let go, it just falls. It doesn't go up into the sky. I've got a quick experiment here. This one is about air pressure. This balloon has air in it, and it's made of rubber. Inside the balloon is high pressure because I just forced the air to go in there. The balloon really doesn't want it. The balloon wants to get rid of the air. So when on TV, when we talk about high pressure and low pressure, if this is high pressure and I let go, it's gone. The reason the balloon flew away is the high pressure in here, that air wanted to get out. And as soon as the air started going out, it pushed the balloon in the other direction. So when we talk about high pressure and low pressure, air goes from high pressure to low pressure. All storms are low pressure storms, whether it's a tornado, a hurricane, or even a thunderstorm. They all have to do with not having a lot of air in one spot, and the wind rushes in to try to fill that air because it's high pressure around it. All right, let's see. I believe, I'm just checking my notes here. All right, so just one last thing to show you. This is another do-at-home experiment. And for it, oh, and by the way, in case you're wondering, how does our rooftop weather station work? It runs off of the sun. This is a solar charger, and you can convert the light from the sun into electricity. Good thing to do. Okay, so the very last thing I'm going to show you is, I'm going to flip this around. Well, actually, I'm not going to flip it. I made something. Can anyone guess what that is? I have a stick stuck in the grass, and it's kind of hard to see, but there's the shadow of the stick. That's a sundial. So the sun, of course, is high in the sky, and if you're in the sun, you create a shadow. And on my sundial, if you look really closely, you're going to see the shadow of my camera here. I have these little rocks, 9 o'clock, 10 o'clock, 11 o'clock, noon, 1 o'clock. Actually, my rocks are off, so I need to move this one over here. So now we're at 4 o'clock, noon, 1, 2, 3. I have to move them all. But the bottom line is, put a stick in your yard At 9 o'clock in the morning, put a rock where the shadow is. At noon, put a rock where the shadow is. At 3 o'clock, put a rock where the shadow is. And then if you separate all of those with 2 more rocks, it's a clock. 9, 10, 11, 12, 1, 2, 3. So there's your sundial. All right, cool stuff in the earth, in the atmosphere. And while I'm at it, take a look at the moon. A lot of people are always surprised to see that the moon is out in the middle of the day. But there it is. It's a waxing, looks like a gibbous moon now, which means it's more than a crescent. Let me back out so it's not too shaky there. And also I'll leave you with a look at our weather station on the rooftop, right above the satellite dish. So there's our weather station. So there you go. Again, thanks for your time and thanks for your patience. Sorry for all the technical hurdles we had, but always kind of cool to talk about weather and weather experiments. Next week, Tuesday and Thursday, I haven't decided exactly what order I'm going to do things in, but I'm going to talk about tornadoes and hurricanes. So tornadoes and hurricanes next week, Tuesday and Thursday. Stay smart, stay safe, stay 6 feet away from people. You know how that goes. And stay tuned to NBC 15 tonight at 5 o'clock. See you then.